All right, so this is the beginning of the journey into Lorentz transformations. So Lorentz, get that's out of the way. Lorentz transformations. And we've established that x squared minus ct squared is equal to whatever the same value is for x prime squared minus ct prime squared. Now in the last video I did ct squared minus x squared, but if that's equal to a constant, then the additive inverse is also equal to a constant. Now in Galilean relativity, so suppose that we have a car going by. So this is a car driving at 50 miles per hour. And we'll make this Earth. So if there is some event going on here, so back up for a second. So we are basically going to establish that when the car is passing by this location on Earth, so this is some location on Earth, this is x sub 0, and this will be, and this is x prime, that when the car passes it, we synchronize it. So x0 prime. So x0 and x0 prime are equal, and t0 and t0 prime are equal. So in other words, when the car passes this particular point on Earth, as the car is driving by, that they make sure that they have the same origin at that moment and the same time. So there is an event that occurs over here at some time t in some position x. So from the Earth's point of view, it happens at some position x and some time t. And oops, my prime is looking a little less prime there. So what is the position and time from the car's point of view? So if we look at Galilean relativity, this is the stuff that we generally use because we don't need to take into account relativistic effects. That we assume in Galilean relativity, time is constant. Time is the same in all reference frames. Therefore, if the car is driven some distance, they're traveling at some speed v, 50 miles per hour, for some time t, then from the car's point of view, this event happened at x minus vt. In other words, I'm claiming that the car passes by here, sometime later this event happens, like imagine an explosion happens or fireworks, we'll make it fireworks. Fireworks happens, and the car has already traveled from the moment that the synchronized clocks to the time that this event goes off, it has traveled some distance vt. So I'm making the claim that that this distance right here, in other words, where the event occurs from the car's point of view, x prime, is going to be equal to where it occurs from the Earth's point of view minus vt. So if this is true up here, then we have x squared minus c squared t squared is equal to x minus vt squared minus c squared t squared, because remember, time is the same in both reference frames in Galilean relativity. So we have x squared minus c squared t squared equals x squared minus 2xvt plus v squared t squared minus c squared t squared. That cancels out, and we're left with this. So 0 equals negative 2xvt plus v squared t squared. Bring that over, so we have 2xvt equals v squared t squared. A v cancels out, a t cancels out, and we're left with 2x equals vt, or x is equal to 1/2 vt, which just cannot be true. So therefore, I mean, we're working on two different assumptions. this assumes time is not the same. This assumes time is the same. This assumes time is not the same. And there's an incompatibility right here. So the Lorentz transformations is how do you talk about an event in the two different reference frames? Because remember, when we deal with simultaneity, just because the two things happen, an event happens at one particular time in one reference frame doesn't mean it happens at the same time in a different reference frame. Or if two events happen simultaneously in one reference frame, does not mean it happens simultaneously in another. So that is the evidence that Galilean relativity is not valid with our assumptions.